the ants underground. Except, what are these big things? They're not larvae, at least not of ants. This is a caterpillar of the small oak blue butterfly, and it has a little nozzle on its back. From it comes a nourishing liquid called honeydew, which the ants collect like dairy farmers. By being useful to the ants, the caterpillars gain their protection. And they're useful for more than just their honeydew. Up on the roof, danger. The caterpillar seems to sense the spider. It signals on the leaf floor. The ants become agitated and prepare for battle, flexing themselves and getting their weapons ready. They peek out to see what the actual danger is. A spider. And then it's all mandibles on deck. They spray at it and drum the leaf, making the sound that gives rattle ants their name. Exit spider. There seems to be a thing between ants and caterpillars. The two are often found together. Dr. Phil DeVries of the University of Oregon has studied caterpillar-ant relationships all over the world.
The interesting thing about caterpillar-ant associations is they're quite literally everywhere in the world. And the butterfly caterpillars associate with ants to gain protection against predators, mainly insect predators. The caterpillars produce a food secretion to the ants, and this is the way they pay for their protection. It's like if you had a bodyguard, you have to pay the bodyguard to protect you. But the problem here is that if you're a caterpillar and you're producing a reward, what stops the ant from simply going, "Thank you very much," and turning around and going back to the nest? One of the more fascinating things that the caterpillars use to keep ants with them is that they produce a call. So you have singing caterpillars, and you have caterpillars singing to ants, and the sounds that they make are attractive to the ants.
What's strange about these sounds is that we cannot hear them. The calls the caterpillar makes do not travel as sound through the air, but as vibrations through the solid plant stem. The ants detect the vibrations using unique sensors on their legs. We need the help of a special microphone.
So, for example, this caterpillar, if we pick it up and we put it on this membrane that I have here, we hear nothing now. But if you use the very sensitive microphone, and as you'll hear, that produces a call. You can quite easily hear the caterpillar singing. Now, think about it. How many caterpillar calls have you heard? And what's neat is that every morning there's a dawn chorus of caterpillar calls that nobody hears.
It was while working in Panama on one particular group of butterflies that Phil DeVries first discovered how the caterpillars made their calls. He noticed that they had two rod-like appendages right above their head, stuck into their collar. Called vibratory papillae, these beat up and down on top of the head, and the head itself moves in and out. The papillae have pronounced rings and move over small bumps like guitar picks on the caterpillar's head.
I was reminded immediately of this, which is the South American salsa instrument called the güiro. There's deep grooves in the appendage, like the güiro, and simply that runs up and down across the head, producing a call. The caterpillars, with their calls, are effectively deceiving the ants, because the caterpillars are talking in ant language. And if there are caterpillars on the moon that associate with ants, I'll bet they make calls too.
So the caterpillars talk to the ants, and the ants protect them and milk them. It's a good deal for both. Except that somehow the relationship between this caterpillar and the rattle ants has developed a strange twist. The caterpillar eats the ant's larvae. Most caterpillars eat leaves, and in a way it's lucky this one doesn't, or the ants would literally be out of house and home. But it does seem strange when what amounts to your cow dines on your children. It's been going on for millions of years, though, and both species have obviously survived. Australian weaver ants, and a normally fearsome spider that has wandered onto the wrong leaf. The ants don't care what reputation a creature has. If it comes too close to their nest, it's simple cause and result. They attack, and clinging to the leaf with special claws on their feet, pin their victim down, carve it up, and take it back to their nest. What enables ants to behave this way in perfect cooperation is that they all have exactly the same instinctive response to the same set of events. They're programmed. It's their strength, but also sometimes their weakness. And this little Thomasid spider, which looks like nothing compared to the monster spider the ants have just dismantled, knows how to hack into the ants' program. It not only smells like a weaver ant, it looks something like one too. The ants tolerate its presence. This spider does not spin a web. It has other ways of hunting. The lethal bite. And the patient wait. Ants, with their social organization, can be the most effective predators on Earth, but cross their wires and they're pushovers. Some kinds of ants, though, are never pushovers. No predator would take on these ants. Army ants. There are about 500,000 in this bivouac. The whole colony, including, somewhere in the middle, the queen. On the march. These ants can barely see. Blindly following chemical trails laid down by their nestmates, they take everything edible in their path. And there's very little anything else can do about it. You could say they're a mob, but more organized and more single-minded. To the wasps watching the pillage of their nest, this colony might be a huge amoeba with tendrils spreading through the forest. But more than an amoeba too, because each of these ants has a brain. Not a very big brain, but all of their processing power added together gives them a kind of collective intelligence. Is that what ants are? A big, many-legged brain? Professor Nigel Franks.
I think that what most impresses people about ants is just how incredibly well organized they are at the collective level, at the colony level, and how incredibly determined they seem to be. Because people think that they're so well organized, they think that they must be organized as we are, but even more so. In other words, that they must have really a rigid hierarchical control with a key person deciding what everyone ought to do and having a sort of chain of command, telling the workers what they ought to be doing.
But most ants, it seems, are organized from the bottom up rather than the top down. No one ant is in control. The individuals organize themselves. It's almost like anarchy that works. It's a formidable evolutionary strategy.
I think what is interesting about army ants is that they're perhaps more likely to start experimenting upon me than I was to start experimenting upon them. So what I chose to do was to look at a very contrasting species. And leptothorax are, I think, one of the absolutely ideal species to keep in the lab. We've got them nesting between glass plates in a very small cavity here. And the beauty of this is that we can watch all the ants all the time and really study their behavior in tremendous detail. And they're just really very, very nice ants. I mean, to get a feeling for the scale of them, I often imagine that it would be nice to have a colony inside your watch. If you took all the gubbins out, a colony could very easily fit into a space like that. What we're interested in with this experiment is how a colony finds a new nest and how it does all the operations to move into it. So what we do is simply tip a colony out onto this platform where there are no nesting opportunities at all, and one scout will find the bridge and walk across, and we'll actually walk around inside this beautiful ideal home on this side, and if it's happy it will go back to all its nestmates. And what it will do is quite extraordinary. It will actually pick up a single worker and carry it all the way back over the bridge, and then they both look round the new home, and if they're both happy, the whole thing snowballs until we've got this enormous stream of traffic from the old colony to the new one.
When the whole colony is safe inside the new nest, some of the workers begin building a protective wall across the entrance. Grains of sand become huge boulders in the jaws of these tiny ants.
Each ant indulges in what I call bulldozing behavior, where they absolutely thrust the building block into the wall and trundle it in. Essentially, they've built a very beautiful retaining wall, and they put it in exactly the right place. So even though this might seem a very odd thing for a scientist to look at, we're looking at how individual behaviors scale up to something that is far more impressive. And actually, I think that that's a really major principle throughout the whole of biology, looking at how simplicity at one level generates more sophistication at a higher level.
Ants are supremely organized, yet there's no hierarchy, no one ant in command. Their organization is unique. Ants are always at the grassroots of the problem they're trying to solve. Each ant is part of the decision-making process. It's the way they've been solving problems for 100 million years. Ants really are the ultimate millennium bugs.